So we need to use the limit comparison test to determine the convergence or divergence of the given series. According to the limit comparison test, if two series, so the first series is AN, the second series is BN, with AN being greater than 0 and BN being greater than 0 for all n, then if the limit of AN over BN, where n approaches infinity, lies between 0 and infinity, then this series either both converge or both diverge. Well, let's say that the given series, let me copy paste it, the given series is AN series. This is the sum of AN and goes from 1 to infinity. So that means that in our case, AN equals 2n squared minus 1 over 3 n to the 5th power plus 2n plus 1. Now let's try to simplify this a little bit. So let me again copy paste this. This equals n squared times 2 minus 1 over n squared over n to the 5th power times 3 plus 2 over n to the 4th power plus 1 over n to the 5th power. So it equals 2 minus 1 over n squared over n cubed times 3 plus 2 over n to the 4th power plus 1 over n to the 5th power. Now let's assume that series Bn, where n goes from 1 to infinity, equals 1 over n cubed. We know that this series is convergent according to P series test. So here P equals 3, so the series is convergent. Now let's look at the limit of AN over BN, where n approaches infinity. It equals this expression. I'll just copy paste it. So the limit of this expression divided by 1 over n cubed, where n approaches infinity. Then this equals the limit of 2 minus 1 over n squared over 3 plus 2 over n to the 4th power plus 1 over n to the 5th power, where n approaches infinity. Since n approaches infinity, 1 over n squared approaches 0, 2 over n to the 4th power approaches 0, and 1 over n to the 5th power also approaches 0. Then this equals 2 over 3. Since the limit of AN over BN equals 2 over 3, which lies between 0 and infinity, that means that series AN and BN behave alike. So if we know that series BN is convergent, then our initial series AN is also convergent. So the answer is convergent.